Okay, students, now we are in the very important topic of the liquid solutions topic. Okay, chapter name is liquid solutions, and sometimes it, sometimes it is called as dilute solutions. In some places, it is called as colligative properties. It is the second year, 12th class syllabus. Okay, and in Raoult's law, we are in the topic of Raoult's law. Okay, very highly important topic of this entire chapter. In this entire chapter, this Raoult's law is very important topic. Let us start with the basics. Right from the basics, we are going to learn about the up to the advanced level. So for that, I require that everybody should be concentrating and try to make the notes and watch the video till end. Then only there will be use, because it is not like a movie to entertain you. It is going to it is going to give you a bright future. Every minute you spend on this channel is going to change your career. Okay, so try. It may not be entertaining. I will try to make it entertaining, but it may not be entertaining. Okay, but if you follow through the every video with carefully and with attentiveness, then your life is going to be entertaining. Okay, so let us start with the Raoult's law. Okay, so before Raoult's law, there are certain simple identifications, representation you should be knowing. Okay, so for that part only, I have drawn this diagram. Okay, so first let us see what is the binary solution. Any solution which contains two parts. Generally they are called as a solute and solvent, and but here both are liquids only. Here both are liquids and both are volatile. Okay, that means we cannot say which is solute, which is solvent. So I am supposing both component. Now instead of saying a term solute and solvent, here in this topic, what term I am going to use? I am going to use the term called as component. Okay, so there are two components. There are how many components? Two component. Okay, this is component A and this is component B. Okay, for identification, I have done this as a empty circle. The empty circle represents the component A, and dashed line circle represents component B. This is the dashed circles. Okay, so that represents compound B. Okay, so both are compound A and compound B. Both are liquids and both are volatile. Volatile means which can be converted into a gaseous state on its own at room temperature. They are called as a volatile. Non-volatile means which cannot evaporate into the gaseous state from the liquid state at the room temperature. They are called as a non-volatile. Okay, so this is component A, this is component B. Now these two are identical container. Okay, and both contains equal quantity of A and B. Okay, so this pressure is denoted with P naught A. What is denoted with P naught A? Here naught represents that it is in pure state. It is in which state? Pure state. P naught A, that is vapor pressure of A in pure state. Okay, now this represents that vapor pressure of B in pure state. Okay, so the pressure exerted in this closed container, when it is left idle for some time, then that pressure is called as P naught B. Not shows that it is not mixed with anything. It is separately available, pure state. Okay, now both are combined together here in the similar identical container. Okay, now it will become a solution. So this solution is called as a binary and both volatile solution. Okay, binary because it contains how many? Two parts, A and B, two components. That's why binary. Both volatile because A also evaporating and B also evaporating. Okay, so here I take only pressure of A, but I cannot write it as a pressure of A. It is written as PA. what it is written as PA. We cannot write circle over here because it is not no more in pure state. It is mixed with somebody. Okay. So this is also vapor pressure of B, but after mixing, that's why it will be PB. Okay. So even though I'm counting only B molecule pressure, there, but still it is called as a PB. Even though I'm counting it as a molecule pressure only, but still it is written as P naught A. Difference between P naught A and PA now it is understood, I think. Okay. So before mixing pure state, it is P naught A. After mixing, it is PA. Before mixing P naught B, after mixing PB. Now some students will get doubt, sir, why more molecule here, less molecule here? Okay, that means both are volatile, but it is not necessary that both should be equally volatile. A is more volatile than the B. Okay, volatility depends on intermolecular force of attraction at the identical condition. On what it will depend on? Intermolecular force of attraction. Intermolecular force of attraction. Okay. Higher the intermolecular force of attraction, lower will be the volatility. Okay. Lower will be the volatility. Is it understood? Higher the intermolecular force, lower will be volatility. Lower will be P naught. P naught will be lower. Okay. Now you can understand where intermolecular force of attractions are stronger in the B. In B, intermolecular force of attractions are strong enough, and in A, intermolecular forces are weak. Therefore, evaporation is more, that is volatility is more, so vapor pressure also more. Okay, but both can evaporate. Evaporation is not to the same extent. Here more extent, here less extent. Okay, and here that will affect when you are dissolving into the solution. Is it understood? So for this purpose only we are going to use the Raoult's law. It is not Raoult's law for this type of this kind of solution. So there I am going to use this terminology. So before explaining the Raoult's law, I want that that terminology meaning should be known to you. Okay. For that purpose only I have written, and each term is explained with the clear diagram. So once you have the clear diagrammatic explanation, then it will be easy for you to understand Raoult's law. Okay. So two things, so P naught A, PA different, P naught B, P different, and IMFA, how it is going to affect it. Is it understood? Okay, now let us see Raoult's law. Okay, now Raoult's law is again I am dividing for your easiness. I am dividing the total Raoult's law into two parts. Okay, so one is for each component, another is for entire solution. Okay, according to Raoult's law, statements of Raoult's law, vapor pressure of a component in the solution. Okay, vapor pressure of a component in the solution. How I am telling it is in the solution? Because there is no knot over here. is equal to is equal to product of its vapor pressure in pure state and its mole fraction in the solution. Its mole fraction in the solution. Okay, so this is the mathematical form of the Raoult's law for each component. Okay, so vapor statement, again I am telling you, while dictating the statement I have written the mathematical form so that time should be saved and it should be easily understood. Okay, so vapor pressure of a component in the solution, no not means no, it is not in pure state. Okay, vapor pressure of a component in the solution equal to product of its vapor pressure in the pure state and its mole fraction in the solution. Okay, so that is the statement. I think I told you to write notes, because that's why I'm not writing the sentence here. Okay, so vapor pressure of each component in the solution equal to its vapor pressure in pure state and multiplied by the mole fraction in the solution. Here you have to be very careful, this mole fraction in the solution. Okay, so why I am specifically telling you, I will tell you some numericals are there. So if you don't utilize this term there, we are going to be difficult to solve questions. Okay, this is the mole fraction of A in the solution. In the numerical session of this Raoult's law, you will come to know the importance of this. Okay, immediately after this theory session, it is better go through the numerical or question session, so that it should be effective to you. Okay, here you will be learning what is the theory and what are the formulas. In that, how to apply the formulas or how to apply the concept to solve the questions. Okay, now similarly, similar formula can be made for the PB also. PB is equal to P naught B into XB. Is it understood? So binary solution, that's why I'm writing both formulas. Okay, now this is for each component. Now coming to the entire solution. Okay, so P solution, according to this, P solution is equal to vapor pressure of A in the solution and vapor pressure of B in the solution. Okay, so but from this what we can write, P naught A into XA plus P naught B into XB. Okay, this is P naught P solution. Okay, this is entire solution depending on the question. Okay, that's why immediately after the theory session, I will suggest you to go through the question session also. Then only will come to know the effectiveness of each and every formula. Okay, so P solution is equal to PA plus PB. This is vapor pressure of A in the solution, vapor pressure of B in the solution. This is vapor pressure of A in pure state multiplied by mole fraction in solution. Okay, vapor pressure of B in pure state multiplied by mole fraction in pure state. Okay, in the solution. Is it understood? So these are the two mathematical forms. So I have given you diagrammatic explanation, and I have given you theoretical explanation, and I have given you mathematical explanation also. Okay, but this topic is such important that you should also study in another explanation also, that is graphical explanation. Okay, Raoult's law I am explaining in how many ways? In 4 different ways. Okay, diagrammatic explanation, theoretical explanation, mathematical explanation, and fourth one I am going to tell you is graphical explanation. Okay, everything is interlinked and this is a sequential. If you study in this direction only, you will be able to understand. Okay, now let's go to the next segment, that is graphical segment. Okay, okay, now you have entered into the graphical segment of the Raoult's law. Okay, which segment? Graphical segment of the Raoult's law, wherein you are going to study graphically. The Raoult's law is going to be studied with the help of the graph. Okay, so normally graph paper you will see 2 axes, but you find here how many? 2 y-axis, 1 x-axis. That is the beauty of this. That's why this graphical explanation is necessary. Okay, in normal graph, if it is a 2-dimensional graph, how many variables are required? Normally we will draw the graph by taking 2 variables only, but here we are taking 3 variables. How many variables? 3 variable on 2-dimensional graph. That is the beauty of this graph explanation. Okay, so here let us take mole fraction of A in the solution. What is this? Mole fraction of A in the solution. It is equal to 1. Okay, now mole fraction of B in the solution will be how much? 0. Why it is 0? Because sum of the mole fraction must always be equal to 1. Okay, that means here only one component is available. Who is that component? A is only available, B is not there, not yet mixed. So if you keep on mixing, the B, then its mole fraction will decrease. Accordingly, there will be increase in mole fraction of B. So suppose this is the point 9. Immediately, without any thinking, you can write it. Okay, like this point 8, point 2, point 7, point 3. Okay, like this, it will keep on decreases and becomes as 0, and it will increases and becomes as 1. Okay, so like this, values will be keep on changing. Is it understood, students? So how many variables we have taken? We have taken two variables, xa and xb. Okay, now on the y-axis, what I'm going to take is pressure. Y-axis, what I'm going to take? Pressure. I am going to take. What I'm going to take? Pressure. Okay, pressure. I am going to take it on the y-axis. Is it understood? And here on this axis, what it is? It is also pressure, but different quantity. Okay, here xa is there. Whatever the pressure will be there, that will be only because of A. Okay, only because of what? A. Is it understood? Now that can be only represented with not. Okay, because of A. Is it understood? But I cannot say here. Okay, so this will keep on decreases and will become 0. Okay, it will become 0. Is it understood? So this graph is only for PA. Okay, PA is equal to P naught A into XA. This is which form? Raoult's law for each component form. Okay, now why it is decreasing? P naught A is constant. P naught A is constant, but still it is decreasing and because becoming 0. Because of what? Because of the XA. Because of what? Because of XA. XA is highest here. So 0.9, 0.8, 0.7, like that, it keep on decreases and becomes as 0. So because of XA, PA is also decreasing and becoming 0. Is it understood? Now let us start here. Here PA is 0, but B is at its maximum position. Okay. So I am drawing the line here. Okay. Now you should get a doubt. If you are sincere student, see here. This line, this point is just below this point. Okay. Why it is? Any idea? Good. Okay. So this shows that A is more volatile, more pressure. B is less volatile, less pressure. Okay. It is not necessary condition. Both should be different and A should be always higher. It is, I am taking it as an example. Okay. So here this point is called as what? P naught B. What it is called as? P naught B. Is it understood? Now this line goes like this. Why it goes like this here? PB is equal to P naught B into XB. PB is equal to P naught B into XB. Okay. So why here XB is equal to 0, PB will be 0. Okay. And XB keep on increasing 0, 0 0.1, 0 0.2, 0 0.3. Likewise, it will keep on increases and reaches to a maximum point. Okay. So at this point, what it is? P naught B. Understood? So this line is for PB, this line is for PA. Now, when I join both of them, when I mix both of them, when I combine both of them, when two compounds are combined, then it will form a solution or not. So I am combining both of them. I am combining both of them. Okay. So this line stands for what? Complete solution. This line stands for complete solution. P solution is equal to PA plus PB. So this is the second form of Raoult's law. What it is? It is the second form of Raoult's law. Okay. So it can be written as P naught A into XA plus P naught B into XB. Is it understood? So this is the graphical explanation. What it is? Graphical explanation of the Raoult's law. Okay. This graph is drawn by taking A is more volatile, B is less volatile. That's why the this line is slanting like this. If B is more volatile, then this line will be slanting like this. If both are equally volatile, that line will be parallel to x-axis. Okay, so this line slantness will be depending on the comparative volatility. What volatility? Comparative volatility. Is it understood, students? So this is about the Raoult's law in all four different forms. Okay, so Raoult's law is applicable. This Raoult's law, what we are studying by considering binary solution in which both components are volatile but not equally volatile. Okay, and we have studied in how many forms? Four different forms. First one we have studied through the diagram. Second one we have studied through the theoretical concept. Then mathematical equation. Finally with the graph. Okay, so I think now every part is crystal clear to you. If every part is crystal clear to you at this condition, then only you will be able to solve the numericals. Okay, if you stuck anywhere in this one, you can kindly come back and read that concept, so that the next session is what? Question session. Okay, in that question session you will be able to solve only when this concepts are crystal clear. Is it understood? Okay, ready to go for the numerical session? Okay, bye, see you in the numerical session or question session, and making you crystal clear concepts through the theory session. Okay, bye.